This is the 8th video and first video, and this is the first video on problems on stress strain. The formulas used here are stress is equal to sigma is equal to P upon A is equal to E modulus of elasticity into strain. For the strain is equal to delta L upon L, or it is sigma divided by capital E, that is modulus of elasticity. For modulus of elasticity, E is equal to stress upon strain. If we substitute the values of stress and strain, then this E is equal to P into L divided by bracket open A into delta L bracket close, or E is equal to sigma into L divided by delta L. The formula used for delta L is P into L divided by bracket open A into E bracket close, or it is sigma into L divided by E, or it is strain into length. P is equal to sigma into A, and for A is equal to P divided by sigma. For area for a solid bar or a wire of circular cross section, it will be pi by 4 into d square. For a hollow bar or a wire, it will be pi by 4 into bracket open capital D square minus small d square bracket close, where capital D is outside diameter and small d is inner diameter. Area for solid rectangle, it is B into D. Area for hollow rectangle will be equal to bracket open capital B into D minus bracket open small b into D bracket close. Area for uniform equilateral triangle will be equal to under root 3 divided by 4 into side square. Now question number 1. An elastic rod 25 mm in diameter and 200 mm long extends by 0.25 mm under a tensile load of 40 kN. Find the intensity of stress, strain and elastic modulus for the material of the rod. This is the problem. Now what is asked is stress, strain and elastic modulus. Let us first come to stress. Stress is equal to P upon A. Substitute the value of P. P is 40 kN. Convert it into Newton. So it will be 40 into 10 raised to 3 divided by, now area. The diameter given is 25 mm. So area will be pi by 4 into 25 square. Put the bracket in the numerator and also put the bracket for the denominator, and then do the calculations. And sit with your scientific calculators and check whether you get the same answer, that is 81.49 Newton per mm square. Now the force P is tensile, so stress also will be tensile, and this is the answer. Sigma is equal to 81.49 Newton per mm square. In the bracket write down tensile. Now let us calculate strain. Strain is equal to epsilon is equal to delta L upon L. Now the delta L here it is given. Extension of the rod is 0.25, so substitute delta L 0.25, and length of the rod is 200, so substitute 200, so 0.25 divided by 200. Do the calculations on your calculator. 0.25 divided by 200 is equal to, you will get this answer, 0.00125, and strain doesn't have any unit. Stress is tensile, so strain also will be tensile. Then comes modulus of elasticity or elastic modulus. E is equal to stress upon strain. Substitute value of stress from here, 81.49, strain 0.00125. So 81.49 divided by 0.00125 is equal to, try it on your calculator. When you are watching this video, sit with your scientific calculators and do the calculations side by side. See to that you get this answer, 65.192 into 10 raised to 3 Newton per mm square. Now this is the second question. A standard steel specimen of 13 mm diameter elongates 0.2 mm in a gauge length of 200 mm long when it is subjected to a tensile force of 26.8 kilonewton. Find the Young's modulus for the material of steel if the rod is known to be in the elastic range. Now, modulus of elasticity or Young's modulus E is equal to stress upon strain. But stress and strain are not given, so we will not use this formula. Let us directly use it as E is equal to P into L divided by A into delta L, where I have substituted value for P for sigma as P upon A and epsilon as delta L upon L. Now I substitute a value. P is 26.8 kilonewton. So 26.8 into 10 raised to 3 in Newton into length is 200 divided by, now area is 13 mm diameter, so pi by 4 into 13 square into the elongation delta L is 0.2, so substitute 0.2 and put the bracket in the numerator as well as for the denominator and then do the calculations. Now here I have given what are the keys to be pressed on, buttons to be pressed on the calculator. For E, bracket open, 26.8 exponential, this is the button at the bottom near the answer, and few calculators you may have the button instead of exponential it will be into 10 raised to x. So 26.8 exponential 3 into 200 bracket close divided by bracket open shift pi divided by 4 into 13, then press the button x square into 0.2 bracket close is equal to, you will directly get the answer as 201.91 into 10 raised to 3 and the unit will be Newton per mm square. If you don't get the answer, very slowly press these buttons without mistake and you will get the answer. Try it. Find the maximum and minimum stress produced in the stepped bar as shown in figure below due to actually applied load of 15 kilonewton. Now this is the stepped bar. The bottom diameter is 25, the top part of diameter is 12 mm and this is the 15 kilonewton and the force is acting towards the body, so it is a pushing force or a compressive force. Now stress is equal to, say in the upper part is sigma 1 will be equal to P divided by A1. P is 15 kilonewton, convert it into Newton, so 15 into 10 raised to 3 divided by area will be pi by 4 into, now for the upper part diameter is 12, so 12 square. Put the bracket in the top also in the denominator and then press the buttons and do the calculations and see that do you get the answer 132.63 Newton per mm square, and force is compressive, the stress also will be compressive. Now the stress sigma 2 in the lower part will be P divided by A2 is equal to, P is again 15 into 10 raised to 3. Now the bar diameter is 25, so area will be pi by 4 into 25 square. So here also put the bracket in the numerator and in the denominator and press the buttons 15 bracket open 15 into 10 raised to 3 divided by bracket open shift pi divided by 4 into 25 square bracket close is equal to, you will get the answer 30.557 Newton per mm square, and this is also a compressive stress. Now they have not asked us what is the stress in the upper part and the lower part, they are asking maximum and minimum stress. So the stress maximum will be maximum of these two, that is sigma 1 is equal to 132.63 Newton per mm square compressive. Stress minimum is equal to sigma 2 is equal to 30.56. Now here if the third digit is greater than 5 and we want to write it in 2 digits, then we increase 1 digit here and we can write it as 6 Newton per mm square, and if this third digit is smaller than 5, that is 1, 2 or 3, then we will write the answer as 30.55 only. So here I'm writing the answer. I'm doing this is called rounding of the digit. So this is 30.56 Newton per mm square and compressive. Question number 4. A bar of cross section 20 mm by 20 mm is actually pulled by a force P. If the maximum stress induced in the bar is 50 megapascal, determine P. If the elongation of 1.5 mm is observed over a length of 3 meter, calculate Young's modulus for the bar. Now, first they want a P, stress and the area is given. Now the basic formula for stress is equal to P upon A. So the force P will be sigma into A. Substitute value of sigma. Sigma is 50 megapascal. 1 megapascal is 1 Newton per mm square. So directly substitute it as 50. Area 20 into 20. So 50 into 20 into 20. So press the buttons on your calculator. 50 into 20 into 20. You will get it 20 into 10 raised to 3. That is 20 kilonewton. And here it is already given that the force is pulling, so it is tensile. Now the Young's modulus is E is equal to stress upon strain, but the strain is not given, so we will write it as E is equal to sigma into L divided by delta L. Sigma is 50 as it is given here, 50 megapascal. Length of the bar is 3 meter. Convert it into mm, it will become 3000, and the elongation delta L given is 1.5, so substitute it as 1.5. So 50 into 3000 divided by 1.5. Do it on your calculators. See that you get the answer 100 into 10 raised to 3 for the modulus of elasticity, or Young's modulus, and the unit is Newton per mm square. Now here is one assignment. I am giving you 4 problems to solve. Assignment number 2. Steel rod 500 mm long and 20 mm by 10 mm in cross section is subjected to axial pull of 300 kilonewton. If the modulus of elasticity is 2 into 10 raised to 5 Newton per mm square, calculate the elongation of the bar. Also calculate the strain induced in the bar. This is the answer given. Try whether you get the same answer. Question number 2. A hollow cylinder 2 meter long has an outside diameter of 50 mm and inside diameter of 30 mm. If the cylinder is carrying a load of 25 kilonewton, find the stress in the cylinder. Also find deformation of the cylinder. Take E is equal to 100 gigapascal. Answer is given here, stress and deformation. Try it out. Third question, a load of 5 kilonewton is to be raised with the help of a steel wire. Find the minimum diameter of the wire if the stress is not to exceed 100 megapascal. Here I am giving the answer. Try it out. Question number 4, a bar 500 mm long and 20 mm in diameter is elongated by 1.2 mm under the effect of axial pull of 105 kilonewton. Calculate stress, strain and modulus of elasticity. Try the answers. Solve these assignments. Be a master. Thank you.